Good day. I hope you are good. So we are actually continuing with the types of triangles. So today we'll be dealing with equilateral triangle, as it is one of the type of equilateral triangles that we are actually tackling. So we've actually covered a few. This is another type of triangle known as equilateral triangle. So if you didn't watch the previous video, make sure that you go and watch them, because these are basics. Make sure that you know them. So the first property of an equilateral triangle is that all angles are equal. Okay, let me just actually write this clearly. All angles are equal. So all the angles in a triangle known as equilateral triangle, all the angles are equal, and all the sides are equal. So this is very, very important, guys. Do not neglect this knowledge or these basics, because some other people in other grades right now, they don't actually know how to solve other problems or other activities. Why? Because they neglected this. So make sure that you do what you know. This is very, very important. So we're going to talk about the equilateral triangle, knowing that all angles and all sides are equal. So this is a very important information that you, as a grade 8 learner, grade 9 learner, grade 10, must know. Even your siblings who are in grade 12 and 11, they must know this, but they don't. So do not neglect it. So all angles are equal, as I've indicated, and all the sides are equal. Right? Now, what we know is that, let me actually name our triangle as triangle ABC. I will name it shortly. Okay. Angle A plus angle B plus angle C equals 180, and angle A plus B is 180, right? Then there isn't sum of angles in a triangle, meaning when we add A, B, and C, we're going to get 180. But what we know, since this is an equilateral triangle, all sides are equal, meaning we're going to take that 180 and divide it by 2 to get 60. Therefore, all the angles, they share same angle of 60. That is an equilateral triangle, and all the sides are equal. I hope it makes sense, guys. So this is very, very important, guys. Very, very important. So we have another triangle. This is the last one that we're going to talk about: a right angled triangle. Right angled triangle. It's not a right triangle, it's a right angled triangle. Why? Because this right triangle contains of what is known as a right angle. I don't know what I was saying there, but so this is the right angle. This is the right angle. This is A, B, and C. So a right angle triangle must contain that 90-degree angle there, the right angle, as I'm going to actually point it out or indicate it. So this is a right angled triangle. Why? Because it has this right angle right here. So this is 90-degree angle. It's a 90-degree angle. This is what makes this triangle to be called a right angled triangle. Why? Because it contains a right angle, right? So what we must know is that we have three sides in all triangles, but this one, this AC side, or the longest side in this triangle, is known as what? Is hypotenuse. This is the name of that side, hypotenuse, and this AB side is known as the opposite side of the right angle triangle. Then the BC side is known as the adjacent. Then in India they call it the base. All right. It is actually a triangle whereby we can use a special triangle where we can use a theorem known as Theorem of Pythagoras. Theorem of Pythagoras. You only use this theorem only in a right angled triangle. I hope that makes sense. This is the theorem: r squared equals x squared plus y squared. This is the theorem of Pythagoras, where opposite in terms of alphabet is y, adjacent is x, and the hypotenuse longest side is r. I hope you understand that. Then r is the hypotenuse, x the adjacent, y is the opposite, right? So r is the hypotenuse, it is the longest side. Hypotenuse is the longest side, hypotenuse. X is the adjacent in terms of alphabets. Then y is the opposite in terms of alphabets. So we only use this theorem in a right angled triangle, not in those other triangles, but only in a right angled triangle, not in a scalene, not in an isosceles or equilateral, but only in a right angled triangle.